Hi Math 30-2s, just moving on with exponents and logs. So what we're going to do today is using logarithms to solve exponential equations, okay? So just as a review from what we've done over the last couple days, it just says here, in lesson 1 of the unit, we solved exponential equations involving a common base. So solve the following exponential equations by converting to a common base. So again, we always hope that we can solve exponential equations by using a common base. That's always kind of our first line of defense, or first line of thought, I should say, when we try and solve exponential equations. So in the first question, A here, you'll see that I have a base of 2 and a base of 32. So the 2 to the exponent of x will stay as it is, but 32 can be rewritten as a power at the base of 2, which is 2 to the exponent of 5, okay? So at this point, okay, it's pretty self-explanatory based on what we've learned before. If I have two powers with the same bases, I simply just equate the exponents at this point, and I say x is equal to 5, and that's it. There's nothing more to do in this question. If there was another step or two I had to do to isolate x, I would do it, but at this point, that's all that I have to do. So x equaling 5 is the solution to the first one. In B, okay, I have bases of 4 and 2 right now, so the common base will be 2. So the number 4 is 2 squared. There's my number 4, and it's still to the exponent of x. The other side of the equation stays as a power with a base of 2, so it's still 2 to the exponent of x plus 3. Now on the left-hand side, a power raised to another exponent, multiply the exponents together, so 2 to the exponent of 2x equals 2 to the exponent of x plus 3. Okay, so I've accomplished my goal of creating powers with the same base. So at this point now, I equate the exponents, which is the 2x equaling x plus 3. So I just carry on, okay, from here, and I go 2x equals x plus 3. Okay, bring the x from the right-hand side to the left, so that'll be 2x minus x equals 3, okay, and that's just 1x, so x is equal to 3, and there is our solution. Okay, so that's stuff that we've done in previous lessons and what we want to be able to do if possible. Now, unfortunately, okay, that's not always going to be the case, and that's what we're going to take a look at moving forward here. Okay, so solving exponential equations by converting to log form. So where we went from exponent to log and log to exponent forms, that's where this becomes really important. So it says, let's start with considering the exponential equation 2 to the exponent of x is equal to 50. Explain why the solution cannot be determined using the above method we did in the first two questions, okay? Well, the reason being is that it's this number 50, right? I cannot write, so 50 cannot be expressed as a power with a base of 2, okay? So therefore, I can't create powers that have the same base. Now in B, it says determine by considering powers of 2, the two integers, okay, again, integers are positive or negative whole numbers, between which the solution must lie. So if you take a look at this, I know 2 to the exponent of x has to equal 50. Well, 2 to the exponent of 5, for example, is 32. So that's not high enough. If I move to the next integral or integer exponent, that would be 2 to the exponent of 6. Well, that takes me to 64. Well, that's too high, right? So this was too low, and this is too high. So therefore, my answer must lie somewhere between 5 and 6, okay? So x will equal somewhere between, okay, 5 and 6. So we'll just leave it like that, and hopefully that explanation, okay, makes sense. Estimate the solution to the nearest tenth, okay? Well, that just takes us basically going onto our calculator at this point, okay, and trying values for x. So if you go, for example, 5 to the exponent, or sorry, if I go, for example, 2 to the exponent of, say, 5.5, that's 45 in a bit. If I go 2 to the exponent of 5.6, you'll see that that's 48 and a half. 2 to the exponent of 5.7, well, that's past 51. So you know what? The answer is approximately, okay, going to be to the nearest tenth, about 5.6. So 2 to approximately the exponent of 5.6 will give us 50. Now, moving on to C, let's figure out how to solve these things algebraically, okay? So it says the equation 2 to the exponent of x equaling 50 can be solved by, and again, here's the key thing we need to focus on, by converting to log form, okay? And therefore solving the resulting equation. Complete the work below and determine 1, the exact solution, and then 2, an approximate solution. So what happens is, okay, first step right here, they just start with the original equation. Step 2, right here, what they do is they convert to log form. So they write 2 to the exponent equaling fifth as a log. So they say log base 2 of 50 equals x. So remember, 2 to the exponent of x equals 50, and that's what we have in the previous step, okay? So what I do from here is I want x all by itself, so what I do is that I take the log base 2 of 50 and write it using a common base, which is what we learned. So this is log 50 all over log of 2, and that's what they mean by convert to log 10, okay? Use a common base, and we took a look at that in one of the last couple lessons. So there is my answer as an exact value. That's exactly what the answer is. It's log 50 divided by log 2. So if I want, and I'll just write it on the side here, so my exact solution is, like I said, x equaling log 50 over log 2. Now, because I've created a solution or an expression that has that common base of 10, I am now able to use my calculator to evaluate that. So you're just going to go log 50 divided by log 2, okay, and you'll see that you get 5.6 to the nearest tenth. Okay, so our estimation was correct to the nearest tenth. Okay, good. Let's move on and try that procedure, okay, with some questions. And again, you'll see that, it becomes more familiar, okay, and you feel a little more comfortable with it the more questions you do. Again, I'll just reiterate, though, at any point, okay, when we're away from each other here in classes, if you have questions, email me. I will get back to you, okay, with either a worked out solution or a written explanation as to how you do something, okay, and I'll make it as clear as I can for you. So solve the following equations expressing the answer as an exact value in log m over log n, and then to 3 decimal places. Okay, so the first one, we start with 4 to the exponent of x is equal to 7. First thing I'm going to do is I'm going to take this exponential equation and write it in log form. So in log form, it would look like this. Log base 4 of 7 is equal to x. Now, if that step itself is giving you trouble, okay, that indicates to me that you probably have to go back and practice the lessons on going from exponential to log form and log form to exponential form, okay? That's all that is. At this point, that step of going 4 to the exponent of x equaling 7 and writing it as log base 4, 7 equaling x, that kind of has to be second nature at this point, okay? That's a skill that we should have now. From here then, I rewrite it like this, log 7 over log 4 equals x. So there is your exact answer in the form log m over log n. So there is actually part 1. Part 2 now is I'm just going to do that calculation on my calculator. So log 7 divided by log of 4. Okay, and when you do that, we will get 1.404 equals x. Okay, and there it is to 3 decimal places. Okay, let's try the next one. So I have 8 to the exponent of x plus 4 equals 40. First thing I'm going to do is take this 4 to the other side of the equation. So I'll have 8 to the exponent of x is equal to 36. Okay, now I will convert to exponential form. So this will be log base 8 of 36 equals x. Okay, so I will have log 36 over log 8 equals x, okay, and that will be my exact value. And then to 3 decimal places, I'm going to go log 36 divided by log 8, okay, and I will get that x has a value of 1.723. And there you go. All right, let's move on. Okay, so a word problem on the next page that says, according to Stats Canada, in the 21st century, Canada's population has been growing at an average annual rate of 1%. The exponential equation that is given p is equal to p naught, or p initial, times 1.01 to the n can be used to predict the population p n years after a known population p naught, or p initial. Okay, and then they give you a nice URL that you can go to, or a QR code you can scan if you want to know more about that. The question, though, reads like this. If the population at the beginning of 2001 was approximately 30 million, estimate the year in which the Canadian population will reach 50 million, and then again, assuming the same average annual rate of growth. We know it won't grow at the exact same rate every year, but for the purpose of this problem, okay, we are going to assume that they tell us to do that. So if I use my original formula here, which is P is equal to P naught, or the initial population, here's the growth rate, 1.01. So again, that's 100% plus an additional 1%. To the exponent of n, I fill in the values that I know. Okay, I know that my final population will be 50 million. So 50 million, 1, 2, 3, 4, 5, 6. Okay, the initial population was 30 million. So 30 million, 3, 1, 2, 3, 4, 5. There's 30 million and 50 million. Growth rate is 1.01 to the exponent of n. Now, if I want to solve this equation, okay, I want to get rid of that a value, or the value that is in front, okay, of the thing that has the exponent, which is our variable. So what that means is I'm going to divide both sides by 30 million. So you're going to have 50 million divided by 30 million. That will equal 1.01 to the exponent of n, okay? Now, hopefully you can see that on the left-hand side of the equation, that will simplify to 5 over 3, okay? The zeros will all cancel each other out. Okay, in terms of value. So now I have 5 over 3 equals 1.01 to the exponent of n. Okay, so what I can do from here is pretty much what I did on the last page. Okay, is I can convert this to exponential form, okay, if I so choose. So this would be the log, okay, of 1.01, okay, 5 over 3 is your argument, okay, equals n. Now, if you want to calculate this using your calculator, which is what they intend you to do, it's going to be the log of 5 over 3 divided by the log of 1.01, and that will equal n. Okay, so now it's a matter of you using your calculator to figure out that value. Okay, so when I do that, okay, you will get a value for n. Okay, that is 51.337, okay, etc. Okay, so what that means is 51.337 years after the beginning of 2001. So you want to know the year, okay? So if I add that year, or that number of years, the 51.337, to the years after the beginning of 2001, that will take you to the year 2052, okay? So there's your answer. 2052 is the year in which it would reach 50 million. Okay? Good. Okay, solving exponential equations using a graphing calculator. So how to solve things graphically. Now, they talk about one method here, which is the intersect method. Okay, I'll mention another method as I'm explaining it so that you guys have more than one option, okay, when solving these things. So it says the main objective in this unit is to solve exponential equations using an algebraic technique. Often, a graphical solution can be used to verify the algebraic solution. In the previous unit, we met the intersect features to solve problems using exponential functions. And when we use the intersect method, basically we graph one side of the equation as y1, the other side of the equation is y2, and then basically we want the x-coordinate of the point of intersection, okay? And that's the key to these questions. So if I move down to the example, what I would do is I would graph, okay, y1, okay, as 4 to the exponent of x. I would graph y2 as 7, and then I'm going to see where those graphs intersect, okay? So when I do that, here's y equaling 7, okay? It is a perfectly horizontal line at 7. And then when I take 4 to the exponent of x, okay, it is going to basically be an exponential graph that goes up like this, right through there, okay? So what I'm really looking for, again, like they mentioned, is the x-coordinate of where the two graphs intersect, okay? And what you'll see when you do that on your calculator, if you remember the steps, second function, trace, calculate, intersect, okay, and find the cursor as close as you can to where the two graphs meet and hit enter 3 times, okay, this value is 1.4, okay, like so, okay? And actually, I apologize, they want it to 3 decimal places, so it is 1.404, okay? And that's what we get. Now that's the intersection method or the intersect method. There is another method, okay, like I said, which is basically called the zero method. Okay, so I'm just gonna write or, okay? The zero method. Now remember, zeros are the same as x-intercepts when we are talking about the graph. So if I wanted to use the zero method, I could graph everything as one function. So in that case, I would be graphing just one function, y is equal to 4 to the exponent of x, and then minus 7, and then looking for basically the x-intercept, okay, or the zero of the function. So what that would look like, okay, when you use your calculator, okay, would be something along these lines, all right? I would graph that function. It again would be exponential. It would come up like this, okay, like so. You would be looking for the x-intercept this time, okay, which again, what do you know? It'll equal also 1.404, okay? So the idea there is if you want to graph the left-hand side of the equation as one function, the right-hand side of the function is the other, you want to find the x-coordinate where they intersect, or take everything to one side of the equation, graph it all as one function, but then you're looking for the x-intercept or the zero, okay? And that will allow you to solve these equations graphically. Okay, solving exponential equations using logarithms. Okay, so this is where it gets a little trickier for sure. And again, I don't think I'm going to post a lesson tomorrow. I'd like you guys to take today and tomorrow to work through this section. It does take a little bit of time, patience, okay, and trust in yourself to make sure that you're doing the process right. And again, any questions, feel free to contact me and I'll help you through it. Okay, so it says at the top here, more complicated exponential equations having two variable exponents, for example, 6 to the exponent of 3x equaling 3 to the exponent of 2x minus 1, cannot be solved by simply converting to log form. So in this question, you can see, right, that the numbers 6 and 3, you're not going to be able to write powers that have the same base. And I also have exponents on both sides that have the variable, okay? So that's usually a good indication that it's probably not going to be a common base. We're probably going to have to use logarithms to basically solve the question. Now here's what happens. I'm just going to jump down to where we start the work and I'll walk you through each step and we will see how to do this and then we'll practice some questions together. So the exact solution, okay, so right here. So the first thing that they do is they just take what's called the common logarithm of both sides. So you'll see they just actually write the word log on both sides of the equation in front of the two expressions. That is it. Next, what they do is they use the power law. So they take the exponents, okay, and they move them down in front, okay? So that's why you see the 3x here and the 2x minus 1 here. Now, what you'll notice on the right-hand side is because this exponent here was a binomial, I put brackets around it when it comes down. If the exponent is not a binomial, okay, like the 3x right here, when it comes down, it just stays as 3x. No brackets are needed in front of it, okay? Now, the reason that's important is because if it's a binomial, basically this log 3 has to get multiplied to the 2x, and then it also has to get multiplied by the 1 in there. That's why you have the 2x log 3 and then minus log 3 on that side. The other side stayed as 3x log 3, okay? From this point, you will notice that there are two expressions that have the x. This expression here and this expression here. So I bring them together on one side. And when the 2x log 3, okay, comes across to the left-hand side, okay, it becomes minus 2x log 3, okay? Now, both of these expressions here and here have the x in them, don't they? So what I do is I factor that x out of both expressions, leaving me with 3 log x minus 2 log 3. Now, all that's left is to get the x by itself, is to divide both sides of the equation by that big, long expression. So on the right-hand side, I still have the negative log 3, but now I have to divide by 3 log x6 minus 2 log 3, okay? And there is your exact answer. That's exactly what it is, okay? So what you would do now is on your calculator, actually use your calculator to evaluate that. So you're going to go negative log 3 divided by 3 log 6 minus 2 log 3, and you can do that all in one calculation. Just please make sure that when you do it, you have brackets around what is in the denominator, okay? So negative log 3 divided by, and then bracket 3 log 6 minus 2 log 3, close the brackets, okay, and divide, and to the nearest tenth, which is 1 decimal place, you will see that x is equal to negative 0.3. Okay, so that's the easy part of the question, right? Using your calculator. Okay, so let's try some and see if you can follow along and understand what I am doing in these questions here. Now, it says use the above method to solve the equations. Okay, compare the solutions to review questions at the beginning of the lesson. So what you'll notice is that actually K and A, which I'll do in red here, I could solve this one by using common bases because 2 and 32 can both be written as powers with bases of 2. And 32 is 2 to the exponent of 5. We did that one at the beginning of the lesson. So x is going to equal 5 here, but they want me to use common logs. So let's take a look at how I do that. So here's A, right? I start with 2 to the exponent of x equaling 32. Now again, I should be using common bases here because it's much easier and faster, but they want me to practice using logarithms. So the first thing I do is I just write log, okay, in front, or take the common logarithm of both sides. So I'm going to go log 2 to the x equals log, okay, of 32. Now, I basically take the exponents, okay, this was the only one that has an exponent, and I bring it down in front of the log expression using the power law. So I'm going to have x log 2 equals the log of 32, okay, and I'm after the variable x, so all I do at this point now is divide both sides by the log of 2, okay, and there is your answer. Okay, there's your exact answer. If I want that as an approximate answer, now in my calculator, all I do is I go into my calculator, okay, and I go log 32 divided by log 2, okay, and again, you see that x is equal to 5, okay, and that's it. Let's try B. Now, B is going to be a little trickier, but we will work through it, okay, and I will write out each step. So I'm just copying down, okay, the original question. Now again, this one could be solved using common bases because 4 and 2 could have a common base, but they want me to use logarithms. Okay, so again, first thing I do, I just write log, okay, or take the common logarithm of both sides. So log 4 to the x, okay, and then log of 2 to the exponent of x plus 3. Okay, so what's going to happen now is these exponents, okay, are going to come down in front. So what I'm going to have now is x log 4. When the exponent comes down here, it is a binomial, so I put it in brackets. X plus 3 log 2. Okay, the left-hand side is going to stay as x log 4, but I have to be careful here, and this is why I put it in brackets, okay, because that log 2 is going to get distributed to each of those terms, okay? So you're going to have x log 2 and then plus 3 log 2. Okay. All the expressions that contain the x I'm going to take to one side, which in this case will be the left side. So I'm going to have x log 4 and minus now x log 2, leaving just the 3 log 2 on the right-hand side of the equation. I factor out the x from both of these terms, so just x, and now it's log 4 minus log 2 equals 3 log 2, and then x equals, so I'll have 3 log 2 all over the big long expression from the other side, so log 4 minus log 2, and there you go, there's your exact answer. You've isolated x. What I can do then is I can put this whole expression into my calculator to see what happens. So 3 log 2 divided by, and remember, brackets around everything in the denominator, log 4 is log 2, and x is equal to 3. There you go. Okay, so again, getting a little tougher, but see how you do with that and practice it. Again, questions emailed to me, I will get back to you. Next, okay, last page here. Show that the solution to the equation can be written in this form and then evaluate to 2 decimal places. So again, show, okay, so that means I'm going to start with this. I should end up with this, okay? And then evaluate means show what the answer is or what the value of that is. Okay, so that means now at that point when we get to the end, punch those numbers into your calculator and see the value that comes out. So I will just start with the original equation, okay? So 4 to the exponent of x plus 2 is going to equal 7 to the exponent of 2x plus 5. So when you take a look at this question, okay, hopefully you can see that I probably would not be able to, or I won't be able to solve this equation using common bases because I have 4 and 7. I'm not going to be able to write those as powers with common bases. So first thing I do, I take the common log of both sides. So I go log on the left side, and the same thing on the right side, so log, okay? 7 to the 2x plus 5. Now both sides have exponents that are binomials, so when I bring them down in front, they go in brackets, don't they? So x plus 2 log of 4 and 2x plus 5 log of 7, okay? So I have to distribute on both sides, okay? Here to here, and there to there, and there to there. Okay, so there's gonna be a lot of work here, okay, a lot of terms floating around. So this is going to be x log 4 plus 2 log 4, and on the other side, 2x log 7 plus 5 log 7. Okay, so again, everything that has x is on one side of the equation. So x log 4 minus 2x log 7 on the left-hand side. And on the right-hand side, I'll have the 5 log 7 that is still there. And now I'll have minus 2 log 4 that has been brought across. Okay, on the left-hand side, I factor out the x. So x log 4 minus 2 log 7. Okay, right-hand side remains unchanged. So 5 log 7 minus 2 log 4. Okay, and then from there, okay, I now just divide both sides to isolate x. So x will equal, on the right-hand side, you have the 5 log 7 minus 2 log 4, okay, all over. And now I will divide by the log of 4 minus 2 log 7. And that is exactly what they asked me to show that it equals. So that is fantastic. And now what I do is evaluate it on my calculator, okay? And I'm going to go 5 log 7 minus 2 log 4 divided by, and then the denominator all in brackets, log 4 minus 2 log 7. Okay, and I get negative 2.78. And there you go. Perfect. Okay, last question, and I will leave you alone for a little bit, okay? Now, the guy with the fake stop sign here, okay, says we can take the log of each side by any exponential equation to any base, but it's simpler to use a calculator base, okay? If the base of an exponential equation is e, it is simpler to use natural logs to solve the equation, as in the example below. So the only difference here, okay, is you're going to see a power that has a base of e, okay, and then therefore we're going to use natural logarithms. So when you see a power with a base of e, we are going to use natural logarithms as opposed to a common log of base 10, okay? That's all that this question is really aimed at or addressing, okay? So again, as an exact value, and then finally to 3 decimal places, okay? So first thing we are going to do here is I will just start by writing out the question. Okay, so 7 times e to the negative 2x plus 9 equals 12. Okay, so I'm going to take the 9 to the other side of the equation first. So 12 minus 9, that's 3. And again, I want to get this 7 out of here. Okay, I only want the power and the exponent left. So this is going to be 3 over 7, like so. Now, just like I did with the other questions, what did I do? I took the common log of both sides. So this time I'm going to take the natural log of both sides. So I'm going to go with the natural log of e to the exponent of negative 2x equals, and then take the natural log of that side. So the natural log of 3 over 7, like so. Okay, hopefully that's okay. So now what happens is on the left-hand side, okay, I'm left with negative 2x, okay, and on the other side I have natural log of 3 over 7, okay, like so, and then I multiply both sides by negative 1/2 or divide by 2, however you want to view it. So now negative 1/2 natural log of 3 over 7. Okay, and there is your answer as an exact value to 3 decimal places. Okay, I input that into my calculator. I go the natural log of 3 over 7 first, then multiply by negative 1/2, and that will give you 0.424. Okay, and we're done. So hopefully you guys are doing okay. You're not sick. You're staying healthy. I will update with test dates, assignments, those things coming up very, very soon. We had a math meeting this morning. We did talk a lot of good stuff about what's going to be coming forward. So you'll see stuff in the next week. Kind of tentatively plan for something next Monday to be seen on the Google Classroom as an evaluation for the last chapter, and we will go from there. So have a good night, you guys. Practice this for today and tomorrow. I will post something again on Wednesday for you to work on. Don't get too stressed. Do as much as you can, and make sure you're taking care of your families, your siblings, your grandparents.